world usage. This is the valid split. We discussed in the previous slide, remember, like valid, test and split. You can see here like test, valid, train. But here you see better partition, right? Partition, that's what we're discussing, right? If you see here, the better partition is like this is the way, like week 1, week 2, week 3, week 4, same week wise we're partitioning, but we did it in a different way. So even a better partitions, what are the better partition? Like multiple train splits, multiple valid and test splits. So train on data for 6 months, like from 6 months, 1 month, 1 week ago, and validate on today data to see how worst performers get over time. So that's what multiple train splits. And then the multiple valid test splits. So evaluate performance on different slices of data, different subgroups, critical slices. So these are the things. Example, object detection for self-driving cars, accuracy on road surfaces with cyclists is most important. So this is an example, critical example. So more data isn't always better. More data we have, like it's like a crowdsource actually. Like the more data, like we let's say 10k, you see the graph like 10k, 20k, and then 100k. Just have more data. Why is model getting worse? You can see the graph here, right? As in the most 100k data getting more as you grow with the more data, it gets actually isn't always better, right? Like you see this interesting graph, like you get the more and more data, it's looking more accuracy, right? So 100k labels internally labeled and high accuracy. It's interesting. And then you see the 1 million label crowdsourced and noisy, right? So labeling the multiplexity example. So let's see the example here for the label multiplexity. Label all entities in the following sentence. Say example, Darth Sidious, known simply as the Emperor, was a dark lord of the Sith who regained over the galaxy as galactic emperor of the first galaxy empire. So this is an example actually. So you can see the table actually, like connector 1, 2, 3, and then entities 3, 6, 4. You can see the annotation there on the table. And then label multiplicity. More expertise required actually. Here, this is where the main thing. More expertise, more difficult to label actually. More room for disagreement. If experts can't agree on a label, time to rethink human level performance. Like that's where the labeling multiplicity actually. Like more expertise required actually here only. So what is the solution here? Clear problem definition and notion training. Need to have a proper training, and then the data lineage. Track where data labels come from. So where we need to track the data labels, where it comes from actually. So these three things are the could be the key solution. And then the last one is the learning methods with noisy labels. That's the important thing. So I given some sample links so we can check it out. And then the programmatic labeling. The last one is the how we're going to label it in a programmatic way. This is the interesting thing we're going to see now. So training data is the bottleneck. Interesting line. Training data is the bottleneck, where you see the data plus algorithm, which is equal to your model. So that's what we trade. That's what we discussed in the previous one. What is data engineering? How we go? How we did transformation? How we clean the data and different types of streaming? Those things we did. So finally, we see here how the data plus algorithm transferred into a ML model. So this is the key differentiator. The data is the key differentiator, and then the algorithms. Algorithms are the increasingly commoditized. So we don't have better If we don't have better algorithm, we just have more data. That's it. So here, if you see 8% per month data, 8% per month, 8 to 9 p differences. But here, if you see in the algorithms, 1 to 2 days, and then less than 1% differences. So how to get training data in days? Let's see. So hand labeling data is, let's see what are the key points here to hand the labeling data here. It's expensive and then non-private, slow and non-adaptive. The expensive one is when subject matter expertise is required. That's where the expensive things. Actually, you need a subject matter expertise here. And then non-private, need to ship data to human nodes. And then slow, it could be very slow actually, right? Time required scales linearly with labels needed. And then the last one is a non-adaptive. Every change requires relabeling the dataset. Then we see the cross-functional communication between the engineers and the SMEs. Let's say the raw data goes in and then comes out with the labels, and then the trained model goes in and then error analysis by the engineers. So this is the interaction you can see here. Code, version, control, reuse, share, decide, and how to version, share, reuse expertise. So labeling functions, LFS, we'll be using this term labeling functions, LFS, encode SMEs heuristics as function and use them to label training data programmatically. So LFS